Good morning, everyone. Sorry, good evening, I believe. Hello.
Good evening. Yeah.
Good morning.
Yeah.
Sorry for the delay. Let me plug in my audios, then we'll start. Yeah. So yesterday we have discussed about what is data warehouse and what is the characteristics of data warehouse, what is OLTP. These all things yesterday we have discussed, right? Is there any doubt anyone has? Hello?
No, Arpita.
Okay, let
Hold
me
on.
share my screen. So today we are going to discuss about what is OLAP. So yesterday you guys learned about OLTP. So today I'm going to teach about OLAP. So OLTP, you guys are clear?
Yes.
Okay, so OLAP is nothing but online analytical processing. So OLAP is generally used for the data warehouse where we do the decision making and aggregation of data. Like yesterday I told you that we are getting the data from the different sources, then we are aggregating it and dumping it in the data warehouse. So OLAP is basically, it will be used for the analyzing and decision making process. And it is generally used for the relatively a small amount of data, and the data in these systems are denormalized. So we'll discuss about what is normalization and denormalizations, but for the time being, you remember that here the data are denormalized and OLAP is used only for the data warehouse where we do the decision making and trained of the data. And compared to the OLTP, OLAP deals with the relatively small amount of the data. Okay. Now coming to this difference between the OLTP and the OLAP. What is the difference between the OLTP and OLAP? OLAP is basically, OLTP stands for online transactional processing. OLAP is for the online analytical processing. So OLTP is used when our day-to-day transactions, like yesterday I told you, like whenever you are doing any transactions in your online applications, whatever the data you are generating, that is your OLTP data. Okay, your real-time data, OLTP data. Whereas the OLAP is data is the historical data we store in the data warehouse. It is generally used for the market decision-making process. Okay, OLTP is the application oriented data. Like in online applications, whatever the data you are entering, that is the OLTP data. Whereas OLAP is the subject oriented data, like particular subject area. Suppose you want marketing data to be analysis and you are pulling marketing data to your warehouse. So this is subject oriented data. OLTP contain current data, like whatever the data you have entered in your online application, that is your current data, recent data, that is your OLTP. Whereas OLAP is the historical data, like the data will not change until and unless anybody go and refresh the data. So that is historical data. OLTP contain detailed data, means whatever data you are generating through your online application or what, that data it will be stored. Suppose you have mentioned that you have bought 30 quantities of some 30 quantities of any item. So that will show in the OLTP as a 30 only. But in OLAP, you can modify the quantity as per your requirement. So that is showing summary data or aggregated data. Yesterday, I told you one example saying that you have in your source data, you have cost price in unit quantity, but you do not, sorry, your cost price in you have unit price and unit quantity, but you do not have cost price. But as per your requirement, you need to get cost price. So how you will get it? Is a calculated value. You will do unit price multiplied with quantity and you will get cost price. So that is the summary data or aggregated data, right? Then OLTP is a volatile data. Volatile means it will change. Suppose today I have done a cash deposit of 1,000 rupees. Tomorrow I'll go and I will withdraw 500 rupees. Then my amount will be 500 in my bank account. So that is getting changes. But in data warehouse, until and unless I'll not pull the recent data, my account balance will still store that 1,000 rupees only. So that is non-volatile. Until and unless user will go and refresh the data, it will not change. Okay. OLTP data is the less history data. It is like 3 to 6 months everyday data, whatever you are generating, that is OLTP data. But data warehouse, we can keep as per your requirement. You can keep 6 months data, 10 years data, is up to you. Okay. Then OLTP is normalized data. What is normalization? Normalization means you will be dividing the data into multiple tables, will building the relationship between tables to avoid redundancy, like duplicate won't be there in normalized data. But denormalized data, it will be having redundancy. Okay. And OLTP data is generally used for running the business, like to store your data, whatever transactions you are doing, whatever the activity you are doing, that is needed for running business. But data warehouse is designed for analyzing the business, how the business is performing, how many customer has registered past 3 months, how much sales we have generated, either we are running on profit or loss. That all things can be analyzed using data warehouse. Then OLTP support ER modeling, means entity relationship modeling. OLTP support, like database, you would have been learned about ER schema, entity relationship schema. If you have not learned, please go note it down and please go and check what is entity relationship schema in database. So OLTP support entity relationship modeling, whereas OLAP support dimensional modeling. What is dimensional modeling? I'll teach you in the next chapter, next class. Okay. Well, dimensional modeling is part of data warehouse, that I'll take care of it. We'll discuss about going forward. So OLTP OLAP support dimensional modeling. So in OLTP, the database size will be keep on increasing because every day we'll be generating huge amount of data. So its size will be 100 MB to GB, and the data warehouse size will be 100 GB to the terabyte. In OLTP, we'll be having few indexes, but in data warehouse, we'll be having huge amount of data. So we'll be having many indexes. Here we'll be having many joins. Here we'll be having some joins. Any doubt in the difference between OLTP and OLAP?
Clear,
Yeah,
Arpita.
yeah, tell me.
So this OLTP data, is this data present in the source file?
Yes, what OLTP data is nothing but your day-to-day transactions data. You are placing the order in the e-commerce site, you are doing any transactions, you are whatever you are ordering something in a big basket or anything, whatever activity you are doing through online application day to day, that all are OLTP data. Okay.
Which is present in the source file, right? Not in the warehouse data.
No, not in the warehouse.
Okay.
Okay. So is it clear, right?
Yes.
Okay. So now we are coming to what is the typical data warehouse. So data warehouse, yesterday I told you that in source system we'll be having multiple data sources. Like you have one, this is one data source, this is one data source, this is one data source. These all are gathering in the OLTP database. From OLTP, it is normalized data. These or whatever the source system data is normalized data, and that data through ETL, like through ETL process, will be loading to the warehouse. And from warehouse, this is warehouse data is the denormalized data. And this warehouse, using this warehouse data, will be using any reporting tool and generating the report. This is the aim of our building the ETL, building the data warehouse. At the end is the business user consumptions. They will be using our data to see the decision. They will take the decision making. They will make the trend to see how their business is doing. At the end, this data warehouse, whatever we are building, it will help business to make the decision. It helps the decision making process. Okay, now coming to the difference between database and data warehouse. As I told you, database contains OLTP data, which stores the data in the form of application for use. Small application, OLTP data will be used helping for running the business, where data warehouse will be helping you to analyze the business. Okay, data warehouse will be like you can pull the data from a flat file, from a on-premises database, from the Excel, and integrate it in a warehouse and take the decision making. Okay, that is the difference between database and data warehouse. Clear? Anyone has a doubt about database and data warehouse?
Clear.
No.
Okay, so what is the difference between database and data warehouse? Let's discuss about in detail. Database is used generally the current data, whereas the data warehouse use historical data. So it is database contains day-to-day operation data, whereas data warehouse contains the long-term operations data. Database, you will be given the access, like your database administrator will be granting the access, like in update access, select access, they will be granting. But in here, the manager analysis will be giving the data warehouse access. Okay, data in the database will be always in the form of input. Always, every day the data comes, every minute, every second the data enters to your database. But data warehouse, it will depends upon the user refresh. Okay, it is the output data which is used for the analysis of the trend. Database is used for the transactions. Data warehouse is used for the analytics. Database has both read and write access, but data warehouse only will be having read access. Nobody will be given permission to go and update the warehouse, because if somebody goes and update their analysis or decision, whatever the report they are generating, that will get error out, or that will get it will be giving the
Affected, I
wrong
think.
yeah, it will give the wrong results. Okay, if somebody will go and today they will modify the particular row or something, it will give you the error result. So database contains few number of records compared to the data warehouse, but data warehouse will contain millions of records with the historical data. Suppose, what is the meaning of this? So database, suppose today, suppose you are staying in California and today you move to the Texas. So your in database, your record will be there as a Texas, but in warehouse, it will be having all the details where when you are staying in the California, when you move to the Texas, all the historical data you will find in the warehouse. But database, only the current data you will find, but data warehouse will be having all the historical data, your history, like where to within 10 years what is your activity was there, everything, like how many years data or how many months of data you are retaining your data warehouse. All the history will be there in the warehouse, but in data you will be getting only the recent data. Database is always normalized. As I said, database doesn't contain any redundant data, but data warehouse will be having redundancy. It is denormalized data. Data view in the database is always relational. It is relational database, but data warehouse is multidimensional. It stores in the form of rows and columns. It is multi-dimensional base. Database contain detailed data, whereas data warehouse contain consolidated data. Why we say database contain detailed data means it will be having all the data like marketing data, sales data, everything. Data warehouse will be having consolidated data. We'll pull the data from the database, we'll aggregate the data, apply transformation, and store it in the warehouse. So that is called consolidated data. Clear, or any doubt in this? Guys, any doubt?
Arpita, I
Yeah.
have a doubt.
Yeah, tell me.
So in database, right, it's a day-to-day live data, right? So how much
Yeah.
it can store, and is it overriding? What happens to the
No,
past
it
data?
will not override now. See, like it depends, like on-premises database and all, it has the limit. But if you'll go to the big data, you will store the data in the cloud. So automatically, if your data will increase, size will also increase. So now, like on-premises data has some limit, but if you are storing the data in the cloud and all, there is no limit. Based upon your capacity, it will also automatically increase.
Okay. And about data warehouse, it's historical data, right? So whenever we
Yeah.
pull more data from database, what happens to the old history that we have? It will keep adding to it, or it will keep overriding to it?
So sorry, can you come up again?
Uh-huh. The data in the data warehouse is a historical data, right? That we
Yeah.
periodically pull from the source, which is the database.
Source. Yes.
So we already have a history. So it's next period to pull the history, pull the data, right? So what
Hmm.
happens to the old historical data? They
See,
add
there
it to
is
it, or
it will be as suppose you are maintaining last 10 years the data, so within 10 years whatever the data you are getting, like if you are getting a person's details for 5 records, then all 5 records will be stored in the data warehouse, but out of that one will be the active record. We'll discuss that. There is a concept called slow changing dimensions, we'll be discussing in that part. So all the
okay.
data will be stores, but in that, out of that, only one will be your active record. Whichever is your recent record, that will be the active record. Rest of the records will be the inactive record. But you will be
Okay.
maintaining the history all.
Okay.
Generally,
Okay.
in data warehouse, there are three types of slow changing dimensions. But in our real time scenario, we generally maintain SCD1 and SCD2. So, what is SCD1 and SCD2? We'll discuss in the going forward. Okay. So now, yesterday you guys were having a doubt for what is the difference between ETL and database testings. Both ETL testing and database testing involve the data validation, but they are not the same. ETL testings normally perform the data validation in warehouse system, where database testing commonly perform on the transactional system, like whatever that OLTP database, like your real-time database, there you perform database validations. And the transactional system data comes from the different application to the transactional database. Okay. But in ETL, we'll be integrating the data and storing it in the warehouse. And in ETL testing, we'll be doing the layer by layer testing, like data acquisition, data transformations, data extractions, then data loading, reporting. All these layer testing will be performing on the ETL testings. Next is what is normalization and what is denormalizations. Normalization is basically a techniques which is used for the organizing the data to remove the redundancy and dependency of the data. It divides the larger table into the smaller table linked by using the relationship. So normalization is basically three types. Let me open in Excel. There are three types of normalization. First normalization, second normalization, and third normalization, and BCNF. Okay. Then first normalizations. First normalizations is every record in the table should be unique. Okay. So what happened? There is a student ID. Then you have phone number. And you have the class, suppose. So S1, then suppose that number is like this something, and class is suppose 10th grade. Then again S1 has one more record, 67890. Then he is also in 10th grade. So basically S1 has two numbers, two phone numbers. Okay, with the same rows. This particular row, this particular student ID has two records in for this particular in one row has two records for this particular, and he is belongs to the class 10th. S2 has S2 has different. Then he is on 6th grade. Then S3 has S5 has, and he is on 3rd grade. So as per the normalizations, every entity should have, every attribute should have a unique record. But here you see the row number 1, the S1 has with the same row, it has two values. So that is a violation of the normalization, first normalization. So what we'll do, we'll divide this data into the multiple row. Like S1 will be having this is the one, this is the one record, and again S1 will having this as the one record. Okay, so then S2 will be having this, S2 and S3 will be this. So basically rule 1 says that the particular attribute in the table should be unique. But here you can see the S1 phone number for S1 has two values. So we divided the data into two rows in this next, in the first normalization. This is the first normalizations. Clear this one?
Yes, Arpita.
Okay, now going to the second normalizations. So second normalization is like it should have it should have like there should be a unique key in each table, and it will depend on the like it should have the primary and foreign key relationship. Like I can say, tell you the student ID, then no, not student ID, it is employee ID, department ID, then it's salary, so here you can see employer ID, department ID, salary, department name. So what is happening that these two will be here in this table, these two will be considered as a composite primary key, and this department name depends on this particular composite primary key, which is our violation of the normalization too. So what we'll do, we'll divide this table into two parts. Like it is employee, salary, and department ID will be there in one table, and then employee, department ID, and salary will be there in one table, and the other table will be having And the other table will be having only department ID and department name. After that, you can join and build the relationship between these two tables. This is normalization 2. Normalization 2 will hold normalization 1 rules, and top of that, that should be a relationship between the two tables. Okay? Clear?
Yes, Arpita.
Okay. Now,
The
normalization.
last point, Arpita, can you just come over one more time?
What last point I mean to say that,
Yeah.
see here, this employee and department ID we are taking as a composite primary key to get the unique record from these tables. Okay.
Mhm.
So
Okay.
what we'll do that, it is a violation of normalization 2. So we'll divide this table into two parts. Like I'll say that employee, department ID and salary in Nivas table, and this department ID and department name is in other table. So this is the normalization 2. Okay. So the third and BCNF, that is the homework. Tomorrow you guys will read and come back. And if you have any doubt, I'll explain you tomorrow. You guys has to go for third normalization and BCNF tomorrow. Okay.
Okay.
Okay. If you have any doubt, we'll discuss first and then we'll go ahead. Then coming to the denormalization and normalizations. So as I say, normalization doesn't contain any redundant data. Its database is less complex and it is faster writes. And denormalizations, it is reading the data is faster and it has more redundant data and it is slower writes, more database complexity because it has more joins. Will be joining a lot of tables and getting the data and loading into the other tables. So it will be having a lot of complex joins. It is data are very inconsistent and it required more storage. Whereas in normalizations, it is slow reads, heavy query can be if you at a time lot of users, if you'll query the data, it may crash the hardwares. Then it doesn't have any duplicate data. Indexing is not efficient due to the table joins. Okay. Denormalization and normalization. Now we'll be going to the data modeling concept. So what is data modeling and why we need data modeling? Data modeling is basically a logical structure of database. Okay, we need to design the database. So how we need to design the database? That is called data modeling, and data modeling is very important in data warehouse. So whenever you will get any technical design document or any document, in that it will be mentioned what sort of data modeling they have done. Either it is conceptual, logical, or physical data model, it will be mentioned. So you to understand how the data warehouse has been built, the data modeling concept is very essential. So let me explain the data modeling. So let me open one. So in conceptual data modeling, you will be having only entity. Entity in the sense, it is the table. We say in conceptual data modeling, it is just entity. It doesn't contain any attribute, no primary key, only entity and relationships will be there in conceptual model. Only you can see here, this is a diagram of conceptual model. Here only you can see the cells data. Then you have only the tables are defined. Entity in the sense it is table and there is no relationship built in the conceptual model. Only product, customer, time, stores, and the sales. These entities are only defined in the conceptual model. It is in the conceptual model, only will define the entities. There is no attribute or primary key is defined in the conceptual model. Coming to the logical model will define entity relationship, the primary key, foreign key, and the normalization occur its label. In logical model, where you will here we have only defined, in conceptual model you have defined only the entity, but in logical model you will be defined all the entities and its attribute and its primary and foreign key relationship, that will be defined in the logical model. Wait a minute. Logical model will define all the entities, primary keys are specified, foreign keys specified, and normalizations will occur. And in physical model, will be defined all the table and columns, display the foreign. Here you can see only I have defined the first one. We have defined only the table name. There is no attribute. Attribute means you cannot see on column names or any foreign key or primary key relationship in conceptual model. If we'll come to the logical model, see here, product number we have defined as a primary key, sales order ID we have defined as a primary key, date ID we have defined as a primary key, stores number we have defined as a primary key, customer number you have defined as a primary key. And in product you can see all the attributes. What are the attributes are there, means what are the columns are there in the table we have defined. We have defined the primary key foreign key relationship. Suppose here you have a product number is primary key, and in sales also you'll find product number. So we'll be joining this table using the product number. So this is the product number is the primary key of product table, and the sales product number is the foreign key of the sales table. So these details we are defining in the logical model. In conceptual model, you have just defined the table name, but there is no attributes, no column names or no relationship are defined. But in logical model, you have defined the column name and its relationship over here. Conceptual model and logical model is clear for everyone, or anyone has doubt? Guys, is it clear? Or you guys are not able to understand? Guys, am I audible?
Yes, all the
Is it
concepts are
clear?
new for us, so we are trying to understand.
Okay. That's what I tell you, every day you need to go through it, you need to read so that you will be understanding, because you are freshers, you do not know anything, so it's a very new concept for you. So, but I just want to, wherever you are not able to understand, let me know, I'll explain it. So you are able to understand what is conceptual model?
Yes.
So conceptual model is nothing but data model is the logical structure of database. What is the data or model looks? That is the logical structure of database. Suppose you are building a warehouse. So basic thing is like you need to build a structure, right? How your tables will be arranged. So that is the data model. So here there are three types of data modeling: conceptual, logical, and physical. So conceptual is the very initial steps where you will differ. Suppose you get a requirement that you need to build a warehouse. So in first whenever you will get a requirement, what you will do, you'll identify what all tables you need for your building the model. So that is the conceptual model. Here we get a requirement and we are identify that we for our end use for our report generation or for our for meeting the requirement, we need these all tables, because these all tables contains the data which we need for the report generation. So the whatever the tables we are identifying it, that is called conceptual model. Clear?
So you're saying
Guys,
we're only defining the tables.
Tables, only defining the table. There is no attribute, no relationship, nothing. You just identified these all tables, will be using it. That is conceptual model. Clear?
Okay.
Okay, now coming
Yes.
to the logical model, we have identified the table like product, sales, customer, date, and stores. But you have not identified the attribute name, whatever attribute you need. Attribute means columns name. So here in logical model, we'll be identifying the column name. Like in the source, we will be having multiple columns, right? Maybe we won't be using all the columns. All the columns may not be required for our data warehouse. So we need to identify what all column we need to pull from the source to the data warehouse. So that is the things here we'll be doing in conceptual model. We'll be identifying the column and the relationship between the tables. Like here you can see this product number is there here in this product table. In sales also we have a product number. So this product number is the primary key of the product table, but the sales is the foreign key of the product number in the sales is the foreign key in the sales table.
So
For
this is
this,
logical model, right?
this is logical model. Yeah. Conceptual model is only you are identifying the table. Logical model, you are already identified the table. You are just identifying the column names and their relationship. That is the logical model. Till this, it is clear, or anybody has any doubt?
Clear.
Clear. Okay. Let's go to the next is the physical data model. So what is physical model or data model? So in physical data model, already you have identified the tables, the attribute name, column name, then primary foreign key relationship, but you have not identified the data type. What is data type? Suppose you the employee ID. Employee ID, how much data length it needs for to stores in the database. So that the way of defining the data type length, that is called data type. Whether the data type can be the integer, it can be the varchar, it can be n varchar. So data type will be defined in the form of int, varchar, float, n varchar. All these stuffs are called data type. I think you guys knows what is data type.
Yes.
Okay, so in database also we have a term called data type. The same way how you will be defining in Python, like integer, float, string. So instead of string, we have in database it is varchar and varchar. Okay, varchar is variable.
What is the difference between varchar and n-varchar, Arpita?
See, in varchar is the variable length, and n varchar is also variable length, but you can say that what you can say here, you can store the numerical data as well.
N-varchar?
N varchar,
Okay.
varchar is the variable length. Like suppose in varchar, right? In
It takes only integers, right?
no, varchar will takes only the text.
String, okay.
It takes
String.
only string, and n varchar
okay.
takes numbers.
Integers.
No, it will take both string
both,
and
right.
integer. Huh?
String
Okay,
and integer, right?
Okay.
Still, I have little doubt. Probably tomorrow I'll clarify it properly. Okay.
Varchar stores 8,000 characters and n-varchar will store
4,500.
Yeah.
4,500. Maximum is 4,500 for n varchar.
Okay, thank you.
Okay.
But
So
varchar is widely used, right?
no, it depends. In SQL Server we use n varchar. The maximum length is 4,500.
Because we have
Okay.
used varchar. I mean, we haven't used n varchar in
See, it
SQL.
depends upon your database. See, SQL Server, we have n varchar, but if you go Oracle and MySQL and all, it doesn't have.
Oh, okay.
So it depends. In SQL, Oracle doesn't have. MySQL doesn't have. So in SQL Server, we have. Even if you go to the Azure SQL and all, there also we have. So logical and conceptual model, you guys have clear?
Yes.
So
Yes.
physical model only physical model after defining this attribute and this column name and the relationship, now we'll be defining the product type length, data type length. Product type is it is varchar or nvarchar, and what is the length? Suppose product type I want to define as a 10 digit, so I'll put nvarchar 10 here. And similarly date will be a date field, so date will be defined as a date. Month will be also date field. Year, no, month can be the integer or varchar. Like I want to store month as a APR as a April, then I'll put it as a varchar. If I want to store month as a 4 for April, then I'll store it as a int. Year is always a int field because year is integer, 2021, 23, like this. So these all things will be defined in the physical model, not in the logical model. Logical model only you will be defining the table, already table column name, primary and foreign key relationship, but in physical model you will be defining the data type and its length. So till this everything is clear, or anyone has doubt? Anyone has doubt in this?
No.
No, clear.
Clear.
Okay, now we are moving to the one more concept called called schema. What is schema? Schema is generally used for you guys have learned about entity relationship schema in database.
No, we haven't.
So I will suggest that you need to at least get basic understanding of database like normalization, entity relationship schema, because it is very much important. See, in data warehouse, you'll be dealing only with the data. So you should have good knowledge on the database concepts. So everything I cannot cover it. So I will suggest you guys to go through it, learn about normalizations, then entity relationship schema. These all are very much important for you to understand. So for dimensional data modeling, we need to understand what is the schema. So I'll tell you, schema is nothing but a collections of entity and relationship in the database. And so the schema contains all the tables, rows, columns, and its relationship that is called the database schema. So so we have two type of schema in this dimensional modeling. The star schema, no, not two type, three type basically. Star schema, then snowflake schema, fact constellation schema. So before going to the schema, I want to explain you what is dimensions, what is attributes, and what is hierarchy. So you first understand this one, then we'll go to the schema. So what is a dimension? Suppose you have a customer table. So the customer table contains all the master data informations. Like it doesn't contain any numerical data. It is contain only the descriptive data. Like customer table contains, see, we have a customer table. Let's take it, a customer table. This is a customer table. What can be the customer table contain? Customer ID, customer name, address, then its age, then we can put like
Gender.
gender, email address, right? These all things will be the customer details. We are not keeping any numerical data, like we are not keeping the data about what is the salary is getting, all these stuffs, and how much order he is placed. I do not have any numerical data over here. I have only the descriptive data about the customer. So this is called a dimension table, which contain the descriptive data of particular table. It doesn't contain any numerical data. So this is called dimension table. Similarly, you have a date dimension. Date dimension will be what should be there in date dimension? Date, year, month, quarter, right? Then these all details will be there. So these contains only about the date fields. So this doesn't have any numerical data. So this is called dimension table, which contains only the descriptive value, doesn't have any numerical data. That is called
Age and
date
numerical data?
dimensions. Which one?
Age.
Age. Age is not a numerical data. It's also a descriptive value. It doesn't contain any calculated value, right? Numerical means calculated value, which you like cells is a numerical data, which we are calculating it and aggregating the data, but you will not aggregate the age. So that is not a not a numerical data.
Okay.
Date dimension, order is the numerical data, customer, product. These all are, no, order is not a numerical, sorry. Customer, product, order, stores. These all are, like here you can see, I have given, see, this product, it is a dimension, date is a dimension, customer is a dimension, stores is a dimension, where self, it is not a dimension. It contains quantity, price, amount. These cells is called as the fact tables. We'll learn what is fact tables, but this which contain what is the dimension. Your interviewer will ask what is dimension. Then you need to say dimension is a descriptive data we store in a data warehouse. So this contain only attribute information. Attribute means column name. It contains the information about an attribute. So product type, product description, this is all called attribute, and the dimension is a table which contain the descriptive data. Okay, clear what is dimension? You guys clear what is dimension?
Yes.
Because these all terminology you will be using everywhere in data warehouse. Dimension, fact, these all you will be using everywhere. So you should know what is dimension.
We are trying to observe, Arpita. Hope when we go again and revise, right? We may have doubt maybe that time.
Okay, I'll suggest that you guys today go through the data warehousing concept, so that whatever I teach you, like see all our interview questions, whenever you are facing any interview, they will ask what is data warehouse, what are the characteristics of data warehouse, why we need data warehouse, then what is the difference between OLTP and OLAP, what are the dimensional modeling, which dimensional modeling we have implemented in your project. These all things they will ask. So you have to be thorough about it. What is normalization and denormalizations? So these all things they will be asking. So you have to thorough about it.
Okay.
Okay. So if I'm teaching and if you are going and not reading anything, that it's of no use. You have to read it at home. So you guys are clear till dimensions. What is the dimension? You got an overview of or you want me to explain more? Guys, you have understood. Yeah, you are all understood it.
Yes, sir.
Any one type of data will be stored, or different kinds of
In data warehouse.
descriptive data stored in database, right? Dimension means.
So
Different
it
type
will
of
show the
data.
category of informations, like for customer, whatever the data you need. If a customer is a dimension, then whatever the data you need for customer, it will store that data. It doesn't contain any numerical data. It will be having only the category of informations. Like it will give you the attribute details. For dimension contain all attribute details. Shall we move?
Okay.
Yeah.
Okay, now coming to the hierarchy. What is hierarchy? Suppose you will see, I want to see the hierarchy of a date. So for date, what will be the hierarchy? First label will be the year. Then you will go for the, if we'll drill down, then it will come as a quarter. Then it will come as a month. then month, then what will come? Sorry, month, then week, okay, then again day, date. This is the hierarchy of a date, right? First high level hierarchy will be year. When you will drill down, you will be see the quarterly data, then month, then weekly data, then day. These sort of details, like hierarchy means one level to the higher level to the lower level. That is called hierarchy. If you're storing the data from the higher to the lower level, that is called hierarchy. Okay. Hierarchy will be, you will be, this is also a terminology in data warehouse. So hierarchy is not a specific label that represent the relationship between different attributes in a dimension. In date dimension, like year, quarter, month, day, these all are called hierarchy of the date dimensions. Hierarchy, you guys are clear? It's very easy. It's like year, month, quarter. If you are drilling down and drilling up means from day to year you are going. Drilling down means from year to day you are coming. That is called drilling down and drilling up hierarchy. It is clear?
Yeah.
Can you
Yeah.
give one more example, Arpita?
I know only the date, but if you'll go for the product, like product also you can go, like product is product, then product type, product model, then model. These all, if you drill down for the product table, then you will get product type, then model, then it's model, you will be getting specification, product type, you will be getting different type of products. So product hierarchy will be like this. Similarly, order also you can do, like order type. Then you can see order items like this. Different, it depends upon you how you are creating it for the hierarchy. Like hierarchy means if you'll go down and down, you will be getting more and more detailed data. Like if I'll drill down for the product, I'll be seeing product type, then it's model details, these all things. Any doubt?
No.
No.
Okay, so, okay, now we are coming to the fact tables. What is fact? Fact is nothing but it contains the numerical data which will be using for the business purposes. Numerical data in the sense, suppose we have a table called order. Order has, okay, let me give you an example to how you will identify the dimension. And order table has, or I can get a data. Let me show you a data instead of getting it. Let's see if I can put one data for you. Yeah. This is the data of a order data. Like here you can see row ID, order date, ship date, then the ship mode, customer ID, customer name, segment, country, region, city, state, postal code, region, then category, product ID, subcategory, product name. Okay, then you have sales, quantity, discount, and profit. So row ID, order date, ship mode, customer. See, I will divide this data into different dimensions. This particular sheet, these particular columns, we have how many columns? Till we almost we have, I think, some around 24 to 25 columns. Okay. So I'll divide this data into different dimension. My first dimensions will be the order dimension. In order dimension, I'll be keeping only the order details like order ID, order date, ship mode. This is my order dimensions. I'm keeping only the order details over here. Next, I'll be creating one more dimension. That is my customer ID, customer name. This is my another dimensions. Then I'll be taking one more dimension. That is segment. I'll be taking a segment dimensions where I'll be putting the segment details. Then I'll be having one more dimension, that is region, where I'll be keeping country, city, and state, postal code, and the region. This is my one more dimension, that is my reason dimensions. Then I'm taking one more dimension, that is product ID, product name. I'm taking in one more dimension. Then category will be my one more dimension. Then subcategory will be one dimension. So you guys are asking me what is another example of drill down and see category, sub product, category, subcategory. The product, if I'll drill down, I'll get category. Then I'll get subcategory. Similarly, region, you can see region is the south. If we'll drill down, there you will see which country. It is like your country is your higher level. Then if you drill down, which region it is? It is in south. Which city? It is in Henderson. Which state? It is in Kentucky. Then what is the postal code? This way you will be storing. This is the hierarchy of the region. Okay. Similarly, product ID, category, subcategory, product name, these all are my dimensions. Coming to these sales, quantity, and this is you can see these all are numerical data. So these data will be storing in a table that is called fact table. Fact table will be building relationship between dimension and fact table using primary and foreign key relationship. But these numerical data will be stored with this in another table which contains the numerical data which will be used for the business purpose, that is called fact table. Okay, I'll show you one example in the database for better understanding. So so this is the dimension table. Okay, so you can see here in customer table, we have customer key, geography key, customer alternate key, first name, last name, marital status, email address, monthly income, total children's, all these details are stored here. This is a dimension table where you can go for the fact table. You will be finding suppose this is an internet cell, fact internet cell. Let's take fact internet cell. Fact internet shells will be having only the keys. See, product key, order date key, customer key. So if I want to build the relationship between dim customer and fact internet cells, then using this customer key, you can see here, let's take only 10 record. And here also we'll take 10 record only. So if we'll do here, see here we have a customer key, here we have a customer key. We'll be joining this two tables and getting the corresponding data. Suppose I want to see the unit price for this particular customer. If he has done any sales, then what is the unit price for this particular customer I want to calculate. Then I need to join these two tables and get the unit price from this fact internet cells. Clear, guys? Or you guys have any doubt, or you want me to explain more? Am I audible?
Yes, Arpita.
So you guys are clear on any doubt?
I can say no doubt as of now, but we have to read more to
Yes, you
doubts.
guys have to read. See, in
Yeah, it's like
internet
we are
you will
only
find
observing
lot of,
the knowledge. We
yes,
don't have
but
any doubts.
you have understood what is dimension and fact.
Yeah.
Okay, see, I'll just show you suppose for this particular customer. Let me show you. Suppose the customer ID. Suppose the customer key is this. I want to see the cells for this particular customer key 1100. So what I'll do, I'll show you what is the use of dimension and fact table, how we build the relationship. So I will do that. Select customer key, first name. I want to see the unit price for this particular customers. So what I'll do, invalid column name customer key. Acha. It doesn't have any data. Let me take some values which is as data. Let's take customer key 2839. Okay, if you'll see, it has the data. This particular customer with last name, he has this much unit price for this particular customer key. Like this, you with joining these two tables, one table will be having only the only the attribute details. Other will be having only the sales detail, only the numerical details. So how we will achieve the values from this how they achieve the values? You need to join these two tables, build the relationship, and extract the data and get the defined output. So this is the use of dimension and fact tables. Instead of storing a data in, see here I have only one table which is all both dimension and fact data, but I'll be dividing the data into multiple dimension and one fact tables. So that ways we are doing in the warehouse also. We'll be having a huge data, we'll be dividing into the multiple tables and storing it. Clear? Guys, clear or not?
What?
This dimension and fact.
Yeah, clear.
Okay, I'll suggest you guys to go through it. Like you have to, whatever I teach you, like what is data warehouse, what is OLTP, what is OLAP, what is normalizations, what are the dimensional modeling, and what is dimension and fact. Tomorrow we'll discuss what are the type of dimension and fact. Then we'll be going to the schema. What is the schema? So before that, whatever I teach you today, you guys just go through it.
Arpita,
Yeah.
would you be sharing this PDF that you are using right now?
Yeah, I can share you with you, but thing is that I have not yet added to this group. So once I'll add, then I'll share with you guys.
Okay. Thank you.
Okay. Okay, that's all from my side today. So we'll be meeting up again tomorrow. And but my suggestion is you guys should go through this, whatever I'm teaching you, or else it's of no use. Okay.
Okay.
Okay, thank you. Thank you everyone for joining.
Thank you. Thank you.
Thank you,
Thank you,
Arpita.
Arpita.
Bye.
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 Mhm.